look at today's lesson. We actually have two topics today. The first one is algebraic substitution, and the second one is a version of Riemann sums. So let's work on the first one, algebraic substitution. So when we do a U sub, we figure out what we want to make U, then our derivative is there, and everything just kind of clean wipes. It's all U du. There are some instances when we do that where we actually have some x's left over. And doesn't necessarily mean that U sub won't work, it just means that you may need to try algebraic substitution. It's really kind of like a second substitution. So we'll do the regular U substitution, and then we will actually substitute again. So let me kind of go through the process and show you. It's like on the first one. So we look at that and we think, okay, well, U is 2x minus 1, right? That's what we would make U. So U would be equal to 2x minus 1. Then du would be 2 dx, so 1/2 du equals dx. So let's kind of go through here. We would have this portion would be taken over by the u, and then this dx would be taken out by the 1/2 du, but notice how we have an x left over. We have an x left over. When that happens, we should try this algebraic substitution technique. It won't always work, and if it doesn't, that means we need to try different, which we'll learn next semester, a different integration technique. But what we would do is try. So what we have established here is a relationship between u and x. Our substitution, we related u and x together. I've used this portion of it. But what if I solve for x? Then I would get an expression with u in it. So that's actually what I'm going to do. That's the algebraic substitution. I'm going to take this and solve for x, and then replace this x with what I get, and see if it works. Okay, so let's do that. So we would have u plus 1 equals 2x, where x is 1/2 u plus 1. All right, so now this portion right here, this piece is going to go replace that x. We're going to take that and we're going to put that instead. So what I have this 1/2 from my u sub portion, and I have this 1/2 from my algebraic sub portion. And I'm going to put them outside the radical, or outside the integral. So we're basically going to have a half times a half, or 1/4. So we have 1/4 outside there. So replacing the x is going to be this piece right here. I already have the 1/2 here, so the u plus 1. And then replacing this would be u to the 1/2. So hopefully we recognize we can't integrate it in this form. We're going to need to rewrite it. So I need to distribute. And that's really the only time this doesn't work is if what we have left over we can't integrate. It could happen. This we can actually integrate. We can distribute the u to the 1/2, and we would get what? U to the 1, so 2 over 2 plus 1 over 2, 3 over 2, and u to the 1/2 times 1 would be u to the 1/2. All good? So now let's do our reversal power rule. Let's go ahead and integrate. So we have 1/4 times, let's see, add 1 to 3/2, we get 5/2, divide by 5/2, multiply by 2/5, u to 5/2, plus, add 1 to 1/2, get 3/2, so plus 2/3 u to 3/2, plus c. Back to plus c. Alright, so I'm going to actually do two things at once. I'm going to distribute this 1/4, and I'm going to put the u back in all at the same time. Hopefully that's not too troubling. So I'm going to do that all in one step and get 1/10 times my u is 2x minus 1, 5 5/2 plus 1/6. 2x minus 1 to the 3/2 plus c. And that is our very first algebraic substitution. How's that? Okay. Now let's look at our next one. So on this one, 1 plus x squared would be kind of where we would go to do a u sub. So u is 1 plus x squared. So du is 2x dx, or 1/2 du equals x dx. That's my u sub part. So this portion right here is my u, right? And I actually only need 1x for my derivative. I just need one of those. I have 5 of them. So I'm going to have to, let's think about it this way. I have this one I'm going to take care of with this. But the other 4, there's 4 right there, I've got to try to do an algebraic substitution with. I've got to try to get rid of them by looking at the relationship that I've already established between u and x and using that relationship to solve for x. So I'm going to move the 1 over, and since I need 4 x's and there's 2 here, I'm not going to square root. I'm not going to go all the way to x because I need 4 of them and here's 2. So basically I need 2 of these, or I need 2 of those. I would replace those 4 x's with 2 u minus 1's. All right, so let's do that. Let's go through that substitution. So I have this 1/2 from my u sub part. And let's see, then we would have u to the 1/2 in here. And I have 4 x's, so we need 2 of these du. Okay. So at this point, again, we can't integrate it like that. We're going to have to, do algebra. We're going to have to FOIL it, distribute the u to the 1/2, get everything all worked out. And I did that already. I'm not going to go through the algebra, but I had already done that. So when you do that, when you FOIL this out, then distribute the u to the 1/2, you will get u to the 5/2 minus 2u to the 3/2 plus u to the 1/2. Right. So now let's integrate. So we have 1/2 times the integral of u to the 5/2 is 2/7 u to the 7/2 minus 2 times. The integral of u to the 3/2 is 2/5 u to the 5/2 plus the integral of u to the 1/2, we add 1 to 1/2, get 3/2, so 2/3 u to the 3/2 plus c. Okay? Alright, so we're just going to do actually a couple things at once. Okay, I'm going to distribute this 1/2, and I'm going to put this u, the 1 plus x squared, back in. Okay, we're going to do all of that at once. And probably have to use more than one line. That's okay. So I get 1/7 times 1 plus x squared, the 7/2 minus, and multiply all that together, and I get 2/5 times 1 plus x squared to the 5/2 plus. Then we get 1/3 times 1 plus x squared to the 3/2. Oh, I might almost say plus c. And we got our plus c. Okay, so that is our second algebraic substitution. All right, let's look at the very last one on here. This up a little bit. So here, We think we can see u would be 2x minus 1. du is 2 dx, so 1/2 u equals dx. Okay, so this is going to turn into a u, and I have an x, an extra x. So I'm going to have to try the algebraic substitution again. I'm going to take the relationship that I have between u and x, and I'm going to solve it for x. So let's see, that would be u plus 1 equals 2x, or 1/2 times u plus 1 equals x. Okay. So I have two halves again. I have this half from my u sub, and I have this half from my algebraic substitution, which is going to make a fourth, right? I'm going to pull out a fourth. Okay, oh, I'm going to have to change my bounds. All right, let's change our bounds. Let's go up here. So let's see, we have u equals 2 times 1 minus 1. That's my lower bound, or 1. My upper bound, u equals 2 times 5 minus 1, or 9. Okay, so I have those bound. And again, I think we've talked about this before. You don't have to write out that work. If you want to do that in your head, you certainly can. I'm just writing it out so we're all clear, make sure we know how we got those numbers, right? The 1 and 9. So I'm going to keep it with u's, and my new bounds are 1 to 9. So let's see. In the numerator, we had 1 plus 1, u plus 1, and the denominator is u to the 1/2. Now we can't integrate that. We've probably encountered those before, where we need to rewrite that. There is no quotient rule in integrals. So if I wrote this as two different fractions, I could do my reversal power rule. So let's just think about it as two different fractions. So 1/4 integral of 1 to 9. So u to the first over u to the 1/2 would simplify to be u to the 1/2 plus 1 over u to the 1/2 would be u to the negative 1/2. And that's what we'll integrate. Next we have 1/4 times the antiderivative of u to the 1/2. Let's see, add 1 to 1/2 is 3/2, so 2/3 u to the 3/2 plus, we add 1 to 1/2, and you get 1/2, so plus 2 u to the 1/2. And now this we would evaluate from 1 to 9. Now we have done several days of that, and just for time's sake for the lesson, I'm not gonna do the f of b minus f of a right now and do all of the arithmetic. I'm just going to tell you that if you were to do that, f of b minus f of a, work it all out, you should get 16/3. 16/3 would be the answer that you would get.